Hello class, welcome to lesson 7.4, which is all about polynomials. By the end of this lesson, you should be able to find the degree of a polynomial, and you should be able to write polynomials in standard form. So some new vocab for this section is polynomial. A polynomial is a monomial, or the sum of monomials. Remember, monomials can be as many it can be as many variables times numbers. As long as you're multiplying, that's fine. This is an example of a monomial. This is an example of a monomial. This is not a monomial because we have a variable in our denominator. This is not an example of a monomial, but this is what is called a binomial. It's where we have two different monomials being added or subtracted together. A trinomial would be if we were to take that and let's say we put a 4x squared plus 3x plus 2. This would be an example of a trinomial. See how there's three terms? Okay, so basically remember, no having variables in your denominator for a monomial. The same thing goes with your binomial and trinomials because they're made up of monomials. So if you have 3 over x, or if you had 3x to the negative 1, remember this is the same thing, so this also doesn't work to have 3x to the negative 1. Okay? So degree of a monomial is the sum of the exponents of all of its variables. We'll look at what that means. The degree of a polynomial is the greatest degree of any term in the polynomial. And standard form of a polynomial is what you will see right here. And that's something else that we will practice together, okay? So example 1, determine whether each expression is a polynomial. If so, identify the polynomial as a monomial, binomial, or trinomial. So if we look at our very first example, 1a, we just have x. So that is just one term, one variable that is considered a monomial because it has positive exponents. It's to the positive first power, not a negative exponent, so that's okay. Letter B, we have negative 3y squared minus 2y plus 4y minus 1. You might look at that and think we don't have a word for a for term, but be careful because we have two terms that are like terms that we can combine. So this is actually negative 3y squared plus 2y minus 1. So this is an example of a trinomial. Okay, so make sure it's in simplest form before you label it monomial, binomial, trinomial. If we look at 1c, we have 5rx plus 7tuv. That is a great example of a binomial. We have two different monomials being added together. That's a binomial. All right, letter D, we have 10x to the negative fourth. As soon as I see that negative exponent, I know it is not a polynomial because it has a negative exponent. And then if I were to look at the second term, I have negative 8x to the bless me, I'm sorry guys, negative 8x to the a. That's a variable for an exponent. So I'd say, and it has a variable as an exponent. So that would be another reason that is not a polynomial. Okay, go ahead and state whether 3x squared plus 2y plus z is a polynomial. And then remember to label it whatever it is. Hopefully you determine that this is a polynomial and it is in fact specifically a trinomial. Go ahead and determine what type of polynomial, if it is one, 4a squared minus b to the negative second power is. Hopefully you saw that negative second power and you said that cannot be a polynomial. If you have questions about those, be sure to ask for help. Example 2, if we are talking about finding the degree of each polynomial, this is where you take all of the variables in your term. So here in 2a we have a monomial. We have 7x y to the fifth z to the first. So this is where, when there's no power written, I encourage you to write that 1 there so you don't forget. The way you find the degree is you take all of your exponents. So we take that 1, we take our 5, and we take our 1, and we add them all together. So the degree of this polynomial is 7. I don't get that 7 because of my leading coefficient. I get that because I added up my exponents. Okay? Now if I were to ask you to find the degree of the polynomial of 2b, the way you do that is you find the degree of each monomial. So you find each one, and whichever one's the highest number, that is the degree of that polynomial. So in this first one, we have 2r to the first to the first. So I know 1 plus 1, this degree is 2. And then I have minus 3r to the first to the second, so I have 1 plus 2, so that's 3. Okay, and then I have minus 7r squared t squared, so I have 2 plus 2. And then I have minus 13, there's no exponent here, so that is just 0. Okay, so now I look, which of my boxed numbers is the biggest? 4, so I'd say this is a 4th degree polynomial. Go ahead and try finding the degree of 11ab plus 6b plus 2ac squared minus 7. Hopefully you got an answer of 3, but if not, be sure to ask for some help or go back and look at what you did. Try to find the degree of 3r squared plus 5r squared s squared minus s cubed. Hopefully here you determined your power was 4. Again, if you have questions, be sure to ask. We're now going to practice writing each polynomial in standard form and then identify the leading coefficient. So standard form, you start with your greatest power, or exponent, greatest power, and then you move to least greatest, power, and end with a constant. Okay, so if we look at this very first one, I look at my exponents and I see I have a squared, a 4, and a 1. So I know I need to start with the highest power there is, and that's a 4. So I'm going to start with 4x to the first. And I know it's positive because there's a plus sign right in front of it. Now I'm done with my 4x to the fourth. I have a second power, and I see there's a minus sign in front of it, so I'm going to take that with my 2x squared. And then I know I'm done with that, and I have a minus 3x to the first. I'm done with that, and I'm left with just a constant. And I don't see a subtraction or a negative sign in front of it, so I know I'm going to add 8. So that is my answer written in standard form. Where I go from there, I want to identify the leading coefficient. Once your answer is in standard form, you look what is the first number in your standard form, In this case, it's 4, so I know my leading coefficient is 4. And then in the second one, I need to do the same thing where I organize from greatest to least and then identify my leading coefficient. So I have a first power, third, second, sixth, and then none. So I remember saying 6 at some point. So look, I have 7y to the 6th. There's a negative sign in front of that. So I'm going to bring it with me. Negative 7y to the 6th. And then I have a third power. So I'm going to add 5y cubed because there's a plus sign in front of that 5. Minus 2y squared. And then I have just a regular y, and it doesn't have a negative sign in front of it, so I know I'm going to add it. Okay, so I'm done with my y. Now I just have my constant, my plus 10. So there's my standard form. And I want to look, where's my leading coefficient? It's always attached to the very first term in standard form. So in this case, it is going to be negative 7 because there's that negative sign right in front of it. So that goes with your answer for leading coefficient. All right, go ahead and write this next polynomial in standard form. Hopefully you ended up with 3x to the 7th plus 9x to the 4th minus 4x squared minus 34x. If you have any questions about that, please be sure to ask for some help. Go ahead and identify the leading coefficient of 5m plus 21 minus 6mn plus 8mn cubed minus 72n cubed when it is written in standard form. Right? So identify the leading coefficient. Hopefully your leading coefficient ended up being 8. If you have any questions on how to get there, be sure to ask. All right, let's look at example 4. We're talking about some medicine. From 2000 to 2006, the number n, which represents thousands, okay? The number n of patients seen by a medical facility can be modeled by the equation n equals t squared plus 2.1t plus 0.8, where t is the number of years since 2000. How many patients were seen in 2005? Okay, so t represents the number of years since 2000. We want to know about 2005. So in our instance, t is going to be the number 5 because it's been 5 years since 2000. So we just have to plug that into our equation. We have n equals 5 squared plus 2.1 times 5 plus 0.8. Okay, so n equals 25 plus 10.5 plus 0.8, or n equals 36.3. Now, if I were to write that out in words, what that means, how many patients were seen, I would say 36.3 thousand. But I don't really like to write out words, so I probably would have put 36,300 instead patients. Okay, so it's up to you on which way you want to write your numbers, but make sure if you put 36.3 that you have that word thousand behind it, okay? Because there's a big difference between 36.3, one, because we don't like to do fractions when it involves people, and two, 36 is a long ways away from 36,300. All right, one last problem for you to try on your own. Good luck. Hopefully you ended up saying that there were about 87 pianos sold in 2004. If you have any questions on those or anything else, please be sure to ask for some help. Have a fantastic day.